Welcome, Calculus BC. This is lesson 1-3, infinite limits, limits at infinity, and curve sketching. Let's begin. So, I got examples here. We have these vertical asymptotes here, and we have the functions either going up to positive infinity or negative infinity. These are the patterns you'll see. So sometimes the left and right side both goes up to positive infinity. Sometimes the left and right side both go down to negative infinity. Sometimes they do different things. And for example, this one's going to positive infinity and negative infinity on the right, and while this one is going to positive infinity on the left, and this one's going to negative infinity on the right. So all these can happen. And I know usually we say when limits, they do not exist when you have vertical asymptotes. We can say, just because they don't exist, we can also say they have infinite limits too. So if a graph's going to positive infinity or negative infinity. And sometimes we might just talk about the left or right side. This helps us describe what a graph is doing. Now, how do you actually figure out if it's positive or negative infinity? Let's say you get an example like this. Okay, you don't have a picture of this graph. Well, let's look at and see what a picture of that graph looks like. So look at this calculator right here. And I'm going to go to my graphs. And I've already typed in the top one, x plus 3 over x minus 2. So let's see what the graph looks like. Now notice it's kind of hard to see. So I'm going to actually zoom in a little bit. And we're going to get a new center, and let's see what it does. Okay, so it kind of centered it weird, but notice it's going down on this side, and it's going up on the right-hand side. But what's kind of weird is I got this line in between, and this is just a quirk in your calculators. Your calculators, or some of the graphing calculators, can't handle asymptotes. So they'll just put a line between because they insist on putting a line between everything. So you don't have to. So don't put that if you're sketching that graph, and some of the calculators are nice and don't do that. So what we have is at x equals positive 2, we have a vertical asymptote, and it's going up on the left and going down on the right. So in this example where I say the limit as x goes to 2 with a plus, that means from the right, my answer is positive infinity. Now, and for number 2, and this is basically 2 from the left, this one will be negative infinity. Now, how do we do this without graphing? What I like doing is just plugging in a value that's, if it says a left or right side limits, just plug in a value that's like just above 2. Try 2.1. And if the value is positive, you're going to positive infinity. If the value is negative, it'd be negative infinity. So plug that in. 2.1 plus 3 over 2.1 minus 2. If you do this, you're going to get 5.1 over 0.1. Both numbers are positive, so positive infinity. In this example, I'll plug in a number less than 2, so like 1.9. So I got 1.9 plus 3 over 1.9 minus 2, which will be positive 4.9 over negative 0.1. It's always going to be a negative number. I mean, just think about this. A number a little bit less than 2, if you do a number a little bit less, minus 2, this will always be negative on the bottom. This will always be positive on the top, so you're going to be going to negative infinity. So you just plug in a number a little bit less or a little bit more. We'll do more examples when we go to class. So limits at infinity. That was limits, were they going to infinity? But sometimes we want to take limits of a function f of x as x is going to infinity, or x is going to negative infinity. So sometimes those approach a number, and sometimes they approach infinity. And here's what a graph of that would look like. So you might have seen a function that looks something like this. You might see a function like this, and I forgot what that's called. But basically, as you go to the left and right, it's approaching a horizontal asymptote on the left and right side. So if this is my function f of x, I would say the limit as x goes to infinity of f of x is going to be 0. I could also say the limit as x goes to negative infinity of f of x is also 0. So sometimes your graphs approach a number. How do you figure out what's approaching? Well, let's say we don't have a graph, we just have some functions. So this is a typical situation you'll see. You have polynomial functions. So one shortcut to doing this is if you're plugging in infinity, and this is understanding infinity math. When you have polynomial functions, only the highest degree terms matter. So let's look at each of these, at the numerator and denominator. So let's look at the top. Only the highest degree term matters because a really, really, really big number to the fourth power is going to be just it's going to be just way bigger than a really, really big number squared. And it's going to be way bigger than 2. Those other numbers just don't matter. So I can actually just scribble these out, and I can scribble out the plus 3, because again, as long as you go to a big number, it doesn't matter. So what I'd really have is 5x to the fourth over 10x to the fourth. And I could just simplify that. Well, the x's cancel, and the 5 and 10 reduce to 1 over 2, so my limit is 1/2. Let's take this example. Again, highest degree terms only matter. So I can actually cancel out 4 of these, and with 4 of these, leaving 1, and these reduce to 1 over 2. So what I really have is 1 over 2x. Now you're going to plug in negative infinity in this case. So I have 1 over 2 times negative infinity, and 2 times negative infinity is 1 over negative infinity, which 1 over infinity always goes out to 0. Just a few notes right here on the side. Now let's keep doing problems first. So same thing over here. Cancel. Most of those cancel out. You're left with 1. This goes to 1 over, and that killed. So it's x over 2. You plug in infinity. You're getting infinity over 2, which actually just goes to infinity. So this was 0. Now, other properties of infinity. Yeah, if you multiply like 2 times infinity, it's just infinity. If you divide by infinity, if you add to infinity, it's still infinity. The other weird case, 1 divided by infinity goes to 0. If you know those, that's kind of the key to all this. And just watching your negative signs too. So other patterns you might see, if the degrees are the same, the limit is just the ratio of the coefficients 5 over 10, which reduces to 1/2. In the case of the middle one, if the denominator is the higher power, then it's always going to go to 0. And because that'll always outweigh the top. And if the numerator is the higher degree, you're always going to go to infinity or negative infinity. So little shortcuts. All right. Radical functions. Now, sometimes this has more than one horizontal asymptote, but let's talk about how you would actually solve these. So still think about the polynomial function, only the highest degree term matters. So in this case, the minus 3 just doesn't matter because as you go to infinity, this 4x squared overpowers it. So I really just have the square root of 4x squared over x. And you can reduce square root of 4x squared to 2x over x. And the x's can cancel, so it's just 2 over 1. So my limit is 2. Now, what about this? So when I go to infinity, it's 2. Cool. But what about when I go to negative infinity? Well, it's the same problem, so the math should work out, and it should be 2 again, right? Because that cancels. This reduces 2x over x, and they cancel, and they go to 2 over 1. However, you have to think when you're dealing with negatives, you have to keep track of your negatives. If you're going to negative infinity, the numerator is always going to be positive because you square root a number, it's positive. It's never going to be negative. But this is always going to be, the denominator in this case is always negative because if you're putting a negative number in, it's going to be negative. It's never positive. When you have a positive divided by negative, your answer should be negative, so it's actually negative 2 in this case. This is still positive, so you always have to kind of check on those negative numbers. All right, I'm going to talk a little bit about curve sketching. So sometimes we want to find like key parts. If we wanted to sketch the function, we look for a few key parts. So maybe like the domain, or we want to find vertical asymptotes or basic, or sometimes end behavior. So let's talk about how you find domain. Domain is just all your x values. And really you're looking for, when you have a fraction, anything where you're dividing by 0 is bad. So anything where x squared minus 2x would equal 0. Well, if I factor it out at x, that's x times x minus 2 equals 0. And that happens when x equals 0 and 2. So my domain is everything except for x. I can say x does not equal 0 and 2 as my domain because it can't. Now vertical asymptotes. Because you'll be dividing by 0 as a fraction, vertical asymptotes will happen at x equals 0 and x equals 2. Your end behavior. This is as you go to infinity or negative infinity. So I'm going to say my limit as x, you have to check both sometimes. X goes to infinity of that function, x plus 2 over x squared minus 2x. Follow the rules we did before. Cancel out the lowest degrees. So you have x over x squared, which is just 1 over x which is 1 over infinity. So my answer is 0. And so the limit as you go to infinity is 0. The limit as you go to negative infinity, it's going to cancel out in the same way and just be 1 over x. So 1 over negative infinity, which is just also going to be 0. So I can say limits, these are my two end behaviors. Limit as you go to infinity or negative infinity are going to be 0. And so if you graph that, just want to kind of, let's say I wanted to set this up a little bit. So you're going to expect to have a vertical asymptote at x equals 0. So there's going to be an asymptote right here. It's going to be an asymptote at x equals 2. And a horizontal asymptote at x equals 0 in this case. And so that means as you're going to 0, it's approaching that horizontal asymptote. It can cross horizontal asymptotes in the middle. It's just as it goes to infinity or negative infinity. And we can graph this. I actually have it on my calculator here, so I'm going to pull that up. And we're going to turn off that one. And it's the second function here. Let's see what it actually looks like. And I'm going to have to change how I zoom in so I can see this better. That's okay. So notice here, if you can see that, it kind of is going to be doing this behavior. Going up, it's approaching 0, approaching infinity. It's going to do this like upside down parabola type thing where it's approaching those asymptotes. And it's going to do this. So there's your function. All right, that's going to be it for this lesson. We'll save the rest.